Is it visible, my slide?
General idea about how things are working and
Okay, so let us start with this topic today. So the polymorphic types and virtual destructors. So till now we have seen that we have created different virtual functions in the base classes, and then we have created some functions. We have inherited those functions in the derived classes, and how they works depending on what we are storing in the base class pointers or derived class pointers. That is the upcasting and downcasting. Okay, so with the same concept, let us see what is polymorphic type and what are the virtual destructor or why they are needed. Okay, so the first 4 points that we have already discussed, that is the dynamic binding and how to declare the virtual functions in the base class and how it will be treated. Okay, and next is from the 5th point, that is a class. If a class is having at least one virtual function, either due to explicit declaration or via inheritance, that class is known as polymorphic type. Okay, so even if you are say your class, you are not declaring anything as virtual, then also it may become polymorphic type if you can inherit some virtual functions. So an object of polymorphic type or polymorphic class is also is known as polymorphic object. And the hierarchy, that means if we implement the inheritance, the hierarchies in which the virtual functions are there in different classes, that hierarchy is known as polymorphic type hierarchy. Okay, so polymorphic type classes, hierarchy of polymorphic type classes. So we all know that polymorphism is a technique that allows us to set a base pointer or reference to any of its derived object, and after the assignment the base pointer or reference act in different ways depending on the traits of the derived object that is currently assigned to. That means how the base pointer or reference will work, whether it will consider its own type, base type, or whether it will consider the type of the object it is pointing to, that depends on if you are using polymorphism in your program, if you are using dynamic binding or virtual functions in your program. Okay, thus we create polymorphism, which literally meaning that many form. Okay, so next we will see a class hierarchy of polymorphic type classes and see how the virtual function works. Okay, so here I have taken the same example that I have discussed yesterday, that is instrument and guitar. So guitar is an instrument, guitar is an instrument, and electric guitar, say it is one more level of inheritance. Electric guitar is a guitar. Okay, so instrument is the base class which is having say which is having these 3 functions, that is tune air, and then the tune air function, and then a virtual function called play for the track T that we have taken, and it will just display which play it is, that means instrument play or guitar play, etc. And there is a function called display notes, disc notes. Okay, so disc notes for this instrument, disc notes. Okay, so all of them, guitar also, it will inherit tune here as it is, because it is not a virtual function. So it will just overload the tune here function. Okay, and then this function is the play function. It is not mentioned here the virtual keyword. Even if it is not mentioned, this will be treated as virtual. Okay, so virtual nature is inherited, the play, this one, and this display notes, this one is also not virtual. Okay, like tune air, it is not also virtual, but it is inherited. And here we have made these disk nodes as virtual in the guitar class. Okay. So see the difference. First, tuner and disk node is not, they are not virtual functions, only play is a virtual function, and we know that whenever inheritance works, they inherit the display function, virtual function. Okay, so play is inherited as virtual and tuner is inherited normally, and it is overloaded, and we have written overridden, and we have written this one guitar tuner to understand this is called from guitar. Okay, guitar class. And this virtual void disk nodes, so disk nodes we have made it as virtual. So in electric guitar, when we do the public inheritance from guitar, when we create electric guitar class, it will inherit all the properties, that means all the functions. So tuner is not a virtual function, again the tuner is inherited and overwritten, where it is showing that it is called from electric guitar. Okay, and play is virtual, so its virtual nature is inherited. And for display nodes, this is the lower hierarchy, that means once it is declared as virtual, it will be considered as virtual. Okay, in the lower hierarchy. So you understand this inheritance, level of inheritance and hierarchy. Is it clear?
Yes, ma'am.
Okay, so next is let us do some upcasting that we usually do. Okay, we have created one guitar type pointer dot start pg, and we have assigned that we have created a new object electric guitar. Okay, and we have assigned its address to pg. Okay, and here also we have done upcasting. We have created one pointer called instrument type pointer, and we have assigned the value of pg there, that means the address it is pointing to. So by default this address it is pointing to an object of electric guitar. Okay, so we are doing the upcasting here. Now like usually we do, I'll try to call all the functions using the base pointer. This is base pointer and this is intermediate base pointer. Okay, so I'll try to call the functions with them, and let's see what happened. That means when static binding happens or when dynamic binding happens. Okay, so output I have given here. Okay, and let us see the logic. So whenever I call this pi arrow tune air, so tune air, it will try to find for any whenever any function, member function is called, the compiler try to find out that whether that virtual version of that function is there or not. So tuner is throughout it is non-virtual. Tuner, nowhere it is mentioned that it is virtual, throughout it is non-virtual. So for tuner, the pointer, this pi, it will not consider which type of object it is pointing to, rather it will consider static binding or its own type, that is pi type, that means instrument type. So what it will print, which tuner it will print? This one, isn't it? Are you getting?
Yes, ma'am.
So this one is, it is printing this instrument tuner. Okay, now comes the play. Okay, now we know that play is virtual. Okay, so here static binding happens, and this call actually calls this particular tuner. And now pi arrow play a. Okay, so which one need to be called? So play a is a virtual function throughout the hierarchy. This is virtual, this is inherited as virtual, and this is also inherited as virtual. Okay, so throughout the thing it is virtual. So if any virtual version of the any function is we found, we will see which object, which type of object this pi is pointing to. So pi is pointing to pg, and in turns pg is a guitar type object, and pg is pointing to the actual address, that is electric guitar. So which which one will be displayed, which play will be displayed, this instrument play or this guitar play or this electric guitar play, which one? Yes, hello, please answer.
My electric. Last row. I said the lowest level.
The lowest level, because it is pointing to PG and PG is pointing to a electric guitar, so it is printing this electric guitar. Okay, now see this disp note. Okay, so disp note, when we are calling with PI, so disp note in PI, in instrument type, it is non-virtual, isn't it? So it is non-virtual in instrument type. Okay, so it will try to find out this disp note is having any virtual version of it in this its type or not, in this class or not. If it is not there, is it there for PI?
No, ma'am.
PI, it is not there. That's why it is printing this one. Okay, so this is again, it is working as, this is instrument type pointer and it is static binding as disp note is non-virtual in INSTR. Okay, so this is the reason why it is printing INSTR display note. And the same thing we have done for PG. So when we call this PG, when we create this PG, okay, so PG is a lower level than INSTR instrument. PG is a guitar type pointer, so it is in the lower level than INSTR, and at guitar level both this disp note and this play both becomes virtual. Okay. So what happens if we call this tune air? Which one will be called? Will it call instrument? So tune air is,
No, ma'am.
tune air is again, it is non-virtual in PG also, in guitar also tune air is non-virtual. Okay, so it will try to find that tune air is virtual, is the, so virtual function it will not find, so it will see that which type of object it is. PG is guitar type of object, so it will print PG play, PG tune air. So that's why this guitar and tune air is tune air is displayed. Okay, now for B what PG is pointing to? PG is pointing to electric guitar and play is a virtual, so PG electric guitar, play will be, so these two are same, because in the hierarchy this play function is virtual throughout it. Okay, so these two are same. It is considering whatever be PG or PI, both are representing this electric guitar. Okay, so is it clear? Are you understanding it? And the last one, are you getting it? Is there any confusion? Tell me then.
Yes, ma'am, it is clear.
So for the last one, that is PG display notes. Now display notes becomes virtual here in guitar class. So this disp note, it will try to find out whether it is virtual or not. Previously it was not virtual. For this one it is non-virtual for PI instrument level, but in guitar level it is virtual. So we will consider what PG is pointing to. PG is pointing to electric guitar, so it will print electric guitar disc notes. Okay, so why this differs? Why this one is instrument display note and why this one is electric guitar display notes? You understand? It changes with the hierarchy. When it is not virtual function, it is not taking down the, it is not considering the type of object PG or PI is pointing to. It is just taking the type of the pointer. Okay, so every time I am telling the same thing, the rule is same. Okay, So are you getting how if there are multiple level of inheritance, how the virtual function works? Are you getting it? So till now we have used single level of inheritance, but now I have introduced multi-level of inheritance. So you get the point? Is there any confusion? You can tell me. Is it clear? Yes? If anyone is having any problem, you can ask me. If you are not understanding this thing, I can explain it again. But this is important. This you need to be understanding. Okay? Is it okay?
Yes, ma'am.
Okay, so I am I'm taking the next point, that is virtual destructors. Okay, so we don't know what is virtual destructor, but here we are introducing it, the virtual destructor. That means we'll be writing down the virtual keyword with the destructors, but whether it is needed or not, or why it is needed, that we are going to discuss. Okay, so I have taken one small example. Just go through the example. Here what I have done, two classes I have taken, class B and class D. As usual, class D is inherited from class B. Okay, so in class B there is a constructor B, and it is passing one argument x. So x, with this x we are initializing this, it's having one data member B1, we are initializing this. Okay, and B1 this is the destructor. Okay, which is non-virtual, and we have taken a normal virtual display function. Okay, that displays the value of B1. Fine. Next is I have created one class D, in which class D is having one integer pointer. Okay, integer pointer P, and B1 is inherited. We know B1 is inherited here, and this is the definition of the constructor of the derived class D, where we are passing two variables, int x and int y. Okay, where x is used to pass, we know that it is the responsibility of the derived class constructor to construct the base class constructor. Okay, so this bx is actually going here, and it is initializing this B1. Okay, and for P, what we have done, for P we have created a new variable y. Okay, y is stored somewhere, so the memory mapping is something like that. Okay, so memory mapping you consider, so whenever we create this type of object in the heap segment, the memory is allocated, and the memory mapping is like that. So once we create, so let me discuss the this one first. So this is the destructor for D, which deletes P. Okay, and this is the virtual function that is inherited from display, and inside the virtual that is from B, the display function, which is virtual, and we are just displaying this the value of B1 as well as the value in P. So star P means value at address pointed by P. Okay, so now what we are doing, when we are creating a base type pointer called pointer base, and we are creating a new object D. Okay, D type object. So whenever this is created, this actually created in the heap segment. Okay, so what happens when we create D? So D 2 4, so this 2, that means this is x, and this is going to this will be the value of pointer P, value at pointer P. Okay, so pointer P is creating a new variable y, which stores value 4 here. This is y. Okay, and this B1 we are passing 2 to B1, that is x to B1 here, x to B1, so it is get initialized to 2. Okay, so are you getting the memory mapping? Is it clear? So pointer base is a pointer base type pointer, which is pointing to this object. Okay, so this is object D. that is created in the heap segment. Okay, so these are the parts. First B1, that is, this is the inherited part from B. So this is inherited from B, and there is a pointer P which is pointing to Y, which stores 4. Fine. Next, if I do so, okay, once we do this creation, so we know that constructors are called automatically. So this you understand how they are created. First the base class constructor and then the derived class constructor. So this much part we know. Okay. Now if we consider this display, what it will display? You tell me what it will display. Pointer base is pointing to this D. So here what happened? This is base pointer and it is pointing to D, derived object. So upcasting or downcasting?
Upcasting.
Upcasting done. So this is cut, this is upcasting is done. Okay. After that, with this pointer, this is a base pointer, we want to access this function display. So what it will see? What it will display? It will check this display function is having any virtual version or not. So display is a virtual function. Display is a virtual function. In base it is virtual function. So what it will display?
It would go to the derived part.
It is considering the derived part, because it is considering the not derived part, it is considering the display, this display. It will consider this display. Why? Because this pointer base is pointing to this one. Pointer base is pointing to a type derived. So it will try to find out the display function that is of type derived. So this function is type derived. So it eventually calls B display and star P. So what it should print? It should print 2 and 4. Right? Okay. Are you getting my point?
Yes, ma'am.
So now next comes this delete pointer base. Okay. So what happened when we delete something? When we delete something, it calls, the program compiler calls the destructors. Okay. So destructor is also a function. So pointer base is which type of pointer? Base type of pointer. So which type of object it will destroy, or which type of function it will call for destruction? B, this B, tilde B or tilde D, which one? Because B is not virtual or D is not virtual. So pointer base will consider its own type and it will call B or D. So are you getting my point? Please answer it, otherwise you will not understand.
Yes,
it will not print D, it will not call D, rather it will call B. Why? Because this B, first you will try to see the destructor function called by delete is of type, is of virtual type or not. If it is not virtual, then it will consider its own type and it will call that destructor that is matching with its type, which is B. Okay. So what happen if we call this delete pointer base? So it will call B. Okay. And B is non-virtual. So what it results? Static binding. Okay. And the object pointed by this base pointer, that will be displayed, that will be destroyed. Okay. So what pointer base is pointing to? The pointer base is pointing to this part, the whole part. Okay. But what actually happens, okay, if a base pointer points to a derived object, during deletion it will delete this part only, that B1 2, the part that is inherited from B. Okay. So if a base pointer is pointer, if a base point, if you are using a base pointer to delete or to call the destructor, it will delete only the base portion that is inherited. Okay, and the non-base portion, this part is for D, this part is for D, isn't it? This part is for D, this part is for D. Only the part that is inherited, that will be destroyed, and the part that is inherited from D will be kept as it is. Okay, so you can see this phenomena as we are just slicing the object into two parts. The same object, this is object D, this is object D, but if we don't have any proper constructor, normally the pointer base, normally as per our logic, the pointer base will consider its own type and it will call its own type of destructor, that is B. And B, what it will do? It will destroy only the part that it has created, only this part. So this part will be destroyed. Okay, and the other part is sliced off. So this is known as object slicing. So now you understand, if we don't have any virtual destructor, what happens? Not the whole portion it is pointing to will be destroyed. That means it is pointing to D, that is fine, but it will destroy only the base instance that is getting inherited. Is it clear? You understand this thing? Hello?
Yes, ma'am.
Okay, so to solve this, to avoid object slicing, we make this one as virtual. Just from the previous one I have made this change. Okay, so doing the same thing with pointer base. Now you see what happens. First B, D, then 2, 4, and now delete pointer base. Instead of B, it is calling this D. Okay, again we have taken this one. So once you call D, the whole object of D will be deleted. Okay, so defining base destructor virtual makes it a polymorphic type, which in turn makes the destructors of all its derived classes in the hierarchy also virtual. That means if we call this as virtual, it will be inherited as virtual and all of them will be considered as virtual. Okay, so it enables dynamic binding of destructor, and it ensures that whenever the thing is deleted, means you call for delete operation, it will delete the whole thing, not only the base part but the whole part. Okay, so here another example where with base pointer we have pointed out a base object, both the type matches. So this display will call this PTR base display, it will call which one, B or D? Which display it will call, B or D? So it will call
D.
This one, D or B? B or D? Which one it will call? Pointer base. Now pointer base is pointing to B and display is a virtual function. So what it is pointing to? B it is pointing to. So it will consider the type of B. So it will display this one, B1. Okay. So once you consider this one, it is actually this, when you create this one, it actually creates this B, and then in between then the 2 will be displayed, or any value of B1 will be displayed. B1 is not, we have not passed any value to B1, yeah, 5, we have passed 5. So 5 will be displayed here, and delete is pointing to this. So this is there is trivial, everything is trivial, because pointer base is pointing, pointer base type is also base type, and B is also base type. B object is also base type object. Okay, so this is trivial, base type object creation, but you understand this thing, na? How this object slicing is avoided. So to summarize it, we can say the destructors must be declared virtual in base class to avoid object slicing, and under the hood C++ compiler typically add an additional pointer to the storage layout of each polymorphic object. So how what happens under the hood, that we will cover in my next class. Okay, so we'll be considering these virtual functions, how the virtual function works, what pointers are there, and how this whole thing happens, what internally happens. That thing we'll be covering in the next class. Okay, so till now, if you have any query, you can ask me. Yes. So is it clear, Vamsi? Is it clear to you? Are you there? Gunja, is it okay?
Yes, ma'am.
Ashraful, you have joined in the very beginning. Is it clear to you? Ashraful Alam? Shayantan? So are you there? I don't think it is a good idea to take online class, isn't it? Nobody is there. All are just switched on the meeting and gone. Okay, so if you have any query, you can ask me in the next class, morning class, Monday. Okay, so let's meet offline on Monday. Okay, so okay, you can leave now.